Welcome to qnawire.
Problem 7.54, we have a 60 kilogram skier at the top of a slope that is 65 meters high, and we're told that friction acts on it as they descend the slope, and we're asked how fast are they moving at the bottom of the slope. Okay, so here, assuming that they're not moving at the top, they only have potential energy, so they just have U1, and let's call that G. And then they have work acting on them as they move down the slope. So then they have work due to the friction acting on them, and that's going to be equal to the kinetic energy at the bottom. So I'll write K2. These are the positions K1, K2, and then 2. So now we just need to plug in what we know, and we'll find what the speed is at the bottom. So we have U1 is 60 times G times 65 meters. And then we have work due to friction is equal to negative 10500 joules. And then K2 is just going to be 1/2 mv squared. Okay, so plugging that all in, we'll have 60. Why am I 6 is turning times G times 65 minus 10,500. That's kilojoules. And then that's equal to 1/2 mass times velocity squared. Okay, so then we know what the mass is, so we can plug that in. I didn't plug it in there because I missed it. But then we should just get velocity equal to 30.4 meters per second. Okay, so now that's part A. Part B is now moving horizontally. The skier crosses a patch of soft snow where mu k is equal to 0.2. We're told that it is 82 meters from this point to this point. The average force of air resistance on a skier is 160 newtons. So we have force is equal to 160 newtons. It's acting against the skier as they're moving, so it's pointed to the left into my diagram. How fast are they going after crossing the patch? Okay, so in this case, we're going to have to write down what each of the pieces are. So we have initial kinetic energy, so that's going to be again be K2. Then we have plus the work done by friction of the surface. So I'll write down S for surface friction. We have work done by the air friction. So I wrote AF. And then that is equal to K3. That's the kinetic energy at position 3. Okay, so again, we know what K2 is. We already found what that is. Or I'll just need to plug it in again. Okay, so then we need to find what the expression is for the work due to surface friction. So WSF is going to be equal to the normal force times our mu sub k times the distance. So we have mu sub k. Normal force is going to be equal and opposite to the force due to gravity. And then times our distance, 82 meters. Okay, so we know what mu sub k is, we know what mass is, we know what g is. So that's just numbers now. We know what work due to air friction is. We're told that that is 160 times 82 meters. That's the distance. And one thing we have to make sure of that is the sign is correct. So these are forces acting to the left. So because the skiers move to the right, those are negative. That's one thing to make sure of. And then we have our K3 is equal to our 1/2 mv3 squared. And let's distinguish that between the 2 here and 2 there. That's velocity at 1.2. Okay, so now we can plug in what we have. If you had found what the intermediate step of finding 1/2 mv2 squared is, you would find that K2 is 27759 joules. Okay, then our work due to the surface force is going to be 9653 joules. And then our work due to air friction is going to be 13120 joules. And that's going to be equal to 1/2 times the 60 kilogram skier times velocity 3 squared. And then finding what V3 is, we find that is equal to 12.9 meters per second. And that's part B. Okay, now part C is the skier hits a snowdrift. So I'll make a snowdrift that penetrates, and they penetrate 2.5 meters into it before coming to a stop. So that's 2.5 meters. What is the average force exerted on her by the snowdrift as it stops her? Okay, so what we need to do is we need to find how much energy they have at that position 3. So, and because the work due to the snowdrift is going to counteract all that over a certain distance, we're going to get an average force. So our energy at position 3 is just going to be kinetic energy. If you had found that intermediate step, you would have found that is 4986. That's just going to be this summation here equal to K3. Okay, and that's going to be equal to the work done by the snowdrift. And that's going to be negative work by snowdrift. Okay, so then that's going to be equal to the force average times the distance. That is 2.5 meters, and that's negative. Okay, so divide by 2.5 and divide by -1, you get F average is equal to -1994 newtons. So negative meaning it acts to the left.